In this episode, we will discuss how to optimize the water conditions in your aquaponics system by looking at the water's pH, temperature, and level of dissolved oxygen. Two important players to know for this episode are the hydrogen ion and the hydroxyl ion, which is made up of hydrogen and oxygen. Despite its placid appearance, water is in a constant state of flux, or change. While a water molecule is popularly known as H2O, each molecule is actually a combination of one hydrogen ion and one hydroxyl ion. Though water molecules might seem stable, their two ions are actually constantly coming together and breaking apart, making water susceptible to changes caused by other forces. Water's ability to change means that you must test the water in your aquaponics system often, so as to maintain a healthy environment for your fish, microbes, and plants. This is done by checking your water's pH, temperature, and dissolved oxygen. pH is short for potential hydrogen because it measures the ratio of free hydrogen ions to free hydroxyl ions in a liquid. The pH scale ranges from 0 to 14. When the number of hydrogen ions equals the number of hydroxyl ions in a liquid, that liquid has a neutral pH of 7. Pure water has a pH of 7. When there are more hydrogen ions than hydroxyl ions, the pH falls. A pH below 7 is acidic. Liquids with an acidic pH include lemon juice and black coffee. When there are less hydrogen ions than hydroxyl ions, the pH rises. A pH above 7 is basic. Bleach and baking soda have a basic pH. Every species has an ideal pH range, so it's important to find a pH that suits all the organisms in your aquaponics system. pH affects how well an organism functions, so a pH that is too acidic or too basic can cause problems, even death. The best pH for an aquaponics system is 6.8. Test the pH of your aquaponics system at least once a week, as naturally occurring processes will constantly affect your system's pH. One such process is nitrification, when microbes convert ammonia to nitrate. Nitrification causes a net increase in hydrogen ions, making your water's pH more acidic, while plants make the pH more basic by releasing ions that attach to the free hydrogen. You might assume that these two processes would cancel each other out, but the effect of nitrification is stronger than the effect of plants releasing hydrogen-loving ions. This means that the pH of a healthy aquaponics system will always be falling, becoming more acidic. In order to prevent your water from becoming too acidic, we need to add a buffer, which is something that will help keep your water's pH in the ideal range. Suggested buffers include calcium hydroxide, potassium hydroxide, calcium carbonate, and potassium carbonate. These will make your water's pH more basic while also adding nutrients for your plants. Water temperature is another variable that must be tested to maintain a healthy aquaponics system. Just as different species have an ideal pH, they also have an ideal temperature, as temperature affects how well the organisms in your system can function. For example, a higher temperature will increase rates of reaction, so your nitrifying bacteria will work faster. However, if it becomes too hot, these same bacteria will stop working and die. Different organisms have different ideal temperatures, so it's important to find a range in which your fish, microbes, and plants can thrive. A good temperature range is 68 to 75 degrees Fahrenheit, or 20 to 24 degrees Celsius. Finally, to maintain the health of an aquaponics system, the system must be in an aerobic state. meaning that there's plenty of dissolved oxygen in the water for your fish, bacteria, and plants to breathe. Oxygen is also a key component in nitrification and helps plants absorb nutrients. Since water can absorb oxygen from the air, increasing the surface area of the water will raise the amount of oxygen absorbed. Surface area can be enlarged by splashing water. You can also increase dissolved oxygen using an air pump to literally pump air into the water. However, in a properly flowing aquaponics system, you don't even need an air pump because the water flow generates enough splash to introduce the necessary amount of dissolved oxygen. Water is a key component of aquaponics. To ensure that your system thrives, you must maintain an ideal level in pH, temperature, and dissolved oxygen.